You were on the phone with Candy.
Okay, here we go. Today we're looking at real zeros of polynomial functions. We'll spend some time on Monday on this as well. Look what we get to do today. Long division. We're going to look at the remainder factor theorems and synthetic division. And that's about all we'll get to today. Okay? So division. A function equals a divisor times a quotient plus a remainder. Okay? And we'll do that right now here. Here we go. So if this is divided by this, we do long division. 2x to the fourth, plus x to the third, plus, this is where you got to be careful now. You don't just go minus 3, because you have to have placeholders for everything, Carly Lurs. Do you need to put down your screen? Are you good? I'm good. Okay. Placeholders, so it's 0x squared plus 0x minus 3. You need to put in placeholders, okay, when you're doing long division. It's divided by x squared plus x plus 1. All right. So I'll let you guys get that written down, and then we'll go about doing the division. So at this point, you ask yourself, what times x squared is 2x to the fourth? And it's 2x squared. So you write 2x squared above 2x to the fourth, and then you do the distributive property to what's on the outside. So it's 2x to the fourth plus 2x to the third plus 2x squared. Then you take what you just wrote down and you change all the signs. Okay? So what if this was all positive, you change them all to negatives. Change the signs on the bottom row and then add. This should always add to 0. The first column should always add to 0. If it doesn't, you screwed it up somehow. Okay? So that's 0. What's 1 plus a negative 2? Negative 1, x to the third. What's 0 plus a negative 2? Negative 2x squared. And then you drop your next one down. Your 0x you drop down. Then again, you ask yourself, what times x squared is negative x cubed? Negative x. So you write a negative x right here. And you do the distributive property to get negative x cubed minus x squared minus x. Then, on the line you just wrote down, you're going to change all the signs. So here they were all minus signs, so now we're going to change them all to plus signs, and we're going to add. So change the signs of the bottom row, and then add. This adds to 0 again, because it should add to 0. If it doesn't, you're not doing this right. Negative 2x squared plus x squared is negative x squared. 0 plus x is plus x minus 3. All right. So then, what times x squared is negative x squared? Negative 1. So then you get negative x squared minus x minus 1. Change the signs in the bottom row. then add to get 2x plus negative 2. And that is going to be your remainder. So you go plus 2x minus 2 over x squared plus x plus 1. Oh, no, I'm running low on battery. I'm going to have to teach from the back now. Sims, did you think I would just stop teaching? Oh. There we go. I got power again. All right. So we good with that? That's polynomial long division. You write your remainder over your divisor. Your divisor is this one right there. Okay, I'm going to scoop. So there is their way of doing it, all written out. Polynomial long division. We just did that. It's on your paper. You're good. The remainder theorem says, if a polynomial is divided by x minus k, then the remainder is r equals f of k. So what's the remainder for this? Well, we're going to divide them. Now, we could do polynomial long division. I don't want to, but I'm going to do it one more time so you see it one more time. What times x is 2x squared? 2x, so we're going to put a 2x here. Do the distributive property. 2x squared plus 6x. What do we do at our bottom row? Change the signs. And then add. This should always add to 0. This adds to negative 7x plus 12. What times x is negative 7x? Negative 7. So you get negative 7x minus 21. Change the signs of the bottom row. Then add. Get 33. 33 is your remainder. Okay? 33 is your remainder. Now, I don't like that so much. I don't like long division that much. What I'd rather do is synthetic division. Okay? Everybody good with this? Can I move slides? Must be. So 33 is the remainder. The factor theorem says a number is a factor if the remainder is 0. So if your remainder is 0, it's a factor. It's common sense. We're not going to spend much time on that. All right. So if it's a factor, it's going to be an x-intercept. It's going to be a 0 of the function. It's going to be called a root. Okay? All those things. Okay? When something is a factor, it's a root of the equation, it's a 0 of the function, it's an x-intercept of the function. Okay? Connecting all the vocabulary together. Synthetic division. I love synthetic division. So much better than long division. Now, I could do long division here, but why? When you can do this. And I know Wheels, she writes her synthetic just a little different than me. So you got to do whatever fits, works for you. But here we go. I'm 3x cubed minus 2x squared plus x minus 5. All we do is write the coefficients. If we skip over a term, we got to put a 0 in for it. But we didn't skip over any here. So we go with the coefficients. And then what goes in the box is what this is equal to 0. So if it's x minus 1, if x minus 1 equals 0, x is equal to a positive 1. The positive 1 goes there, not negative 1. Positive 1. You always drop your first term down. 3. And then you multiply 3. Then you add 1. Then you multiply 1. Then you add 2. Then you multiply 2. Then you add -3. So what does that tell us? 3, 1, 2, -3. That makes no sense. Well, it does if you know that this is x cubed, and when you drop 1, it becomes x squared. So this is the equation. This is the equation 3, or the, not the equation, the expression 3x squared plus x plus 2 with the remainder of -3 over x minus 1. That's what we'd get if we do long division. But synthetic is so much easier because we don't have to worry about variables. We just worry about numbers. Multiply, add, multiply, add, multiply, add. Easy peasy lemon squeezy. Okay? Synthetic division. Okay? What if this would be a 0? What would we know about x minus 1? It would be called a what? It would be a factor. Or a 0. 1 would be a 0. Or 1 would be the x-intercept. Okay? Know your vocabulary, because they'll call it each of those things. Okay? All right. So synthetic division. Hey, look at that. It matches my answer. Okay. We're not going to worry about the rational zero theorem until next time. So, synthetic division, long division. There's like 9 problems to do. I'm going to let you guys get started on them now. Escape. Discard. Boom. 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 Stop.